You ever wonder what makes some software systems last for decades, while others become these terrifying black boxes that nobody wants to touch after just a couple of years? Well, today we're diving deep into that exact question. How do we build systems that don't just work now, but actually age well? This isn't about trying to avoid every single failure. It's about designing for longevity. So let's get into the blueprint for building systems that are truly built to last. We have this dramatic image of system failure, right? Like a huge, catastrophic event where everything goes down in a blaze of glory. But the truth is, that's not how it usually happens. Big, sudden implosions are actually pretty rare. The real danger, well, it's a lot quieter. And that is the real enemy. It's the slow creeping decay. It's the system that gets just a little bit harder to deploy every single month. It's the one where all the important knowledge lives inside one person's head. The one that everyone on the team is secretly afraid to modify. This is the slow death that most systems really face. Okay, so how do we fight this? First, we have to actually agree on what a healthy system even looks like. Then we'll dig into the invisible forces that are constantly working against us. From there, we'll lay out a practical blueprint for building for longevity. We'll learn how to spot the warning signs in practice. And finally, we'll talk about the mindset shift that makes all of this possible. All right, first things first. We have to completely rethink what we mean by success. Because way too often, we end up chasing metrics that look great on a quarterly report, but end up creating massive problems down the line. So we're all taught that the ideal system is totally bug-free, perfectly optimized, and has every feature imaginable. But chasing that perfection creates something incredibly fragile. A truly healthy system is something else entirely. It's one where you can make changes safely. It's one where failures are survivable, not catastrophic. The real litmus test, can a brand new person on the team actually figure out how it works? That's what health really looks like. And this is so key. A flashy launch or some incredible performance benchmarks don't mean a thing if the system becomes an unmaintainable mess a year later. The true test of quality is time. Does it endure? Can it evolve? That is the real measure of success. So if longevity is what we're after, what's stopping us? Let's take a look at those invisible forces that are constantly trying to pull our systems apart. Here it is. This is the fundamental conflict at the heart of so much of our work. The very things that get you praised or promoted, raw speed, explosive growth, shipping more features, are often the exact opposite of what a system needs to survive long term. We're rewarded for moving fast and optimizing everything. But health requires slack. It requires simplicity, clear ownership, and a pace that doesn't burn everyone out. What helps you succeed in the short term can actively sabotage your long-term viability. And that conflict leads directly to all of these culprits. Technical debt isn't just about sloppy code. It's the sum of all of the compromises we made for speed. Chasing metrics encourages us to cut corners, and staff turnover is a killer. Every time a senior person leaves, a piece of the system's brain literally walks out the door. It's a downward spiral. Which brings us to this crucial point. If you do nothing, your system will get worse. Entropy is the default state of the universe, and it applies to software too. Health is not a destination you just arrive at one day. It's something you have to actively, continuously maintain. It's like tending a garden. You can't just plant the seeds and walk away. Okay, so how do we actually fight back against this natural decay? We need a plan. So here are 5 core principles that act as a blueprint for building systems that are really designed to last. First, and honestly, this might be the most important one of all, value simplicity over being clever. We engineers love a clever solution, right? But clever code is brittle code. It's hard to understand, and it's impossible to fix when you're paged at 3 a.m. The real test is this. Can you explain how it works to a new teammate in under 5 minutes? If the answer is no, it's too complex. Period. Next up, make your trade-offs explicit. Look, every single engineering decision is a trade-off. We might choose speed over perfect consistency or cost over raw performance. The problem isn't making those trade-offs. It's making them unconsciously, because hidden trade-offs are just time bombs waiting for some future team to step on them. Document why you made a choice. It is an incredible gift to your future self. Now, this one is a huge mindset shift for a lot of people. We're trained to see any kind of slack as waste, to optimize for 100% utilization. But a system with zero slack, no extra server capacity, no buffer in the schedule, no bandwidth for the team, is incredibly brittle. It just shatters at the first sign of trouble. Slack is not inefficiency. It's the space you need to absorb shock, to learn, and to be resilient.
You can't fix what you can't see. Simple as that. A healthy system needs to be able to tell you how it's feeling. And this is more than just basic monitoring. It's about having deep visibility into its behavior, getting early warning signs when things start to drift, and having tight feedback loops so you can learn from every incident. A healthy system, in a way, is self-aware.
And finally, ownership. A system without a clear owner is basically an orphan. It's the one that never gets security patches, the one whose documentation is 5 years out of date. Clear responsibility means somebody is on the hook for that system's long-term health. They are its steward, its caretaker, making sure it doesn't fall into that slow, predictable decline.
Okay, so we have the principles, but what does this actually look like in the real world? How can you tell if a system is healthy or if it's heading for serious trouble? Let's get into the concrete signs.
A healthy system is, well, kind of boring. And that's a good thing. It just works. Changes are predictable. When there is an incident, the response is calm, not chaotic. An unhealthy system, on the other hand, runs on pure adrenaline. It burns people out. It makes developers afraid to make changes. It normalizes outages until they're just part of the background noise. Eventually, it becomes that untouchable thing nobody wants to deal with.
You can spot the decay when you see these anti-patterns. If the only way to fix something is to call that one person who knows the magic incantation, you've got a problem. If every little change requires an all-nighter and heroic effort, you're on a fast track to burnout. And we've all seen it, the temporary workaround that's been running in production for 3 years. These aren't just quirks, they are massive red flags.
And this really is the ultimate truth here. We love to celebrate the heroes, the engineers who swoop in at 2 a.m. and save the day. But if you constantly need heroes, it means your system is fundamentally broken. A healthy system is maintained by regular people, doing their jobs during normal working hours. It should not rely on unsustainable heroisms. Ultimately, all of these principles and practices, they boil down to one thing: a fundamental shift in perspective. It's about lifting our heads up from the day-to-day and changing our sense of time.
We really need to redefine what best even means. It's not the system with the highest throughput on its launch day. It's the system that is still running, still providing value, and is still maintainable 5-10 years from now. The real goals are understandability, adaptability, and trust.
This is really a call to think bigger, to think about the people who are going to inherit this system long after you've moved on. It means choosing the long-term health of the system over hitting a short-term deadline or juicing one specific metric. It requires a kind of professional generosity. And that's what this all comes down to, really. Building systems that are meant to last isn't just a technical task. It is an act of stewardship. It's about taking care of something so that it can continue to serve its purpose long into the future. It's about leaving things better than you found them. And that is a legacy worth building.